So now that we have seen the definitions of even and odd, let us practice our first proof together. This one says, prove or disprove the following statement. The sum of any two odd integers is even. So since this is our first proof, how do we go about proving something? First of all, it says prove or disprove, so you have to kind of follow your gut feeling. You have to kind of try some examples maybe on a scratch paper and give yourself an idea whether you think this statement is true or false. So like for example, in this case, they're saying the sum of any two odd integers. So maybe start by picking two odd integers, I don't know, 3 and 5, and add them because they're saying sum. What is the answer going to be? Well, it's 8, which is even. How about if I did it again with other two odd numbers? I don't know, maybe 1 plus 13. The answer is going to be 14, which is also even. So far it seems like the statement has worked a couple times. So I'm starting to lean towards the fact that this is maybe a true statement. So what I'm gonna do is basically make an educated guess and say that I think the statement is true, and now I'm going to try to prove it. So how can I prove it now? Well, first of all, the proof. I'm gonna start by indicating where the proof begins by writing the word proof. And next, I'm gonna pick two integers, and I want them to be odd because they said make sure that the integers that you pick are odd. Now, I'm gonna put the little brackets right here, and this is a comment to myself and to the reader. This tells the reader what I want to do in the problem. So far I've picked two integers, and I wanted them to be odd. So these are my two arbitrary but particular numbers from the domain. And I want to show that their sum is even. Since both a and b are odd, then by the definition of the word odd, what do I know? Well, if they're odd, that means that there's other integers such that a is going to be 2 times that integer plus 1, and b is going to be 2 times that integer plus 1 also. Notice how I picked two different letters, m and n. I did not pick m and m again. If I did that, then I would be saying that a and b are 2m plus 1 both, which means that a and b are both equal, which is not true in this case. We don't have to have a and b be equal. This is the reason why I picked two random m and n integers. Now, I want to consider the sum of a plus b, which can be written as 2m plus 1 plus 2n plus 1. This is by direct substitution. I know that a is 2m plus 1, so I just substitute it. I know that b is 2n plus 1, so I just substitute it. And I give the justification on the side. With the distributive property, I can erase the parentheses, and then I can add like terms. The 1 plus 1 can be added together because they're both integers. The solution turns out to be 2. And now I'm seeing that there's a 2m, 2n, m plus 2, which means I can factor the 2. Now keep in mind that m and n are themselves integers. So adding them together and adding 1 on top of that still keeps the quantity an integer. We actually call this the closure of integers under addition. So in other terms, if you add integers, you stay integer, which is important because now a plus b is suddenly 2 times an integer. But if a plus b is 2 times an integer, that makes it an even number by the definition of even. So that means a plus b is even, which is what we wanted to show, and the proof is over. So normally, at the end of the proof, we put this little square that indicates that the proof is done. There are other times when people write the letters Q, E, D. That means the end of the proof as well.